increasing, this is worth 1 point. The green function, as you read it from left to right, is it increasing or decreasing?
Decreasing.
Decreasing, right, going down. And that's because my base is between 0 and 1, makes it a decreasing function. If it had been a reflection, it would have made it if there'd been a negative out front, then it would have turned into an increasing function. But you just read it from left to right. And then D, identify the domain and the range of the green function with 4 points. So the domain, normally for an exponential function, is all real numbers. Shifting it left 1 unit is not going to affect all real numbers. So our domain is negative infinity to positive infinity. Our range is low to high. So normally it's 0 to infinity, but we shifted down 3 units, and we now have this horizontal asymptote. So now my range is negative 3 to infinity. That was worth 4 points. So for those of you who took the test, what you missed on that page is in the bottom right-hand corner, circle. So let's go to page 2. I'm going to go over to the other board over here. Number 6. Number 6 is one of the financial questions. It says if $12,000 is deposited in a bank account that pays 1.5% annual interest, what will be the value of the account after 15 years if it is compounded A monthly, B continuously? Okay. So, first of all, our principal that was invested, $12,000. The annual interest rate was 1.5%. Changing that to a decimal, going 2 places to the left, 0.015. Time in years, 15 years. So question A, compounded monthly. That means the number of compounding periods per year is 12 per year. And so with periodic compounding, you're going to use this formula, A equals P times 1 plus R over N to the power N times T. So you have to know that formula. So putting all of that information into that formula, A equals P, 12,000, times 1 plus R, 0.015, over over N, 12, to the power N 12 times T 15. So simplifying the power there, 12,000 times 1 plus 0.015 over 12 to the power 12 times 15 gives you 180. So you're going to put that in the calculator. If you have trouble putting that in the calculator, see me about this, but you're going to first divide 0.015 divided by 12, hit equals. Add 1, hit equals. Use the power key, raise that to the power 180, hit equals. Multiply that result times $12,000. And so rounding that to the nearest dollar, that's going to turn into $15,025.76, rounding to the nearest cent, since it's money. So that was worth, A was worth 4 points, 6A. 6B, rounded, compounded continuously. So with continuous compounding, we have a different formula. A equals P times E to the RT, or R times T. So by the way, I don't remember who it was, but 1 or 2 people here used the wrong formula. Daily compounding, which is 1 day, once a day, is different than continuous compounding. So 1 or 2 people use the daily compounding formula. That's not the same as continuous compounding. You get slightly different result. So for continuous compounding, you need to use this formula, the one with the E in it. You get slightly different result. So we're going to use this formula. So again, P was 12,000 times E is 2.718 approximately, to the R, 0.015 times T, 15. So we've got 12,000 times E to the 0.225. So this is where you use the E to the X key in your calculator. Take E to the power 0.225 and multiply that result times $12,000, and that means it will turn into $15,027.87. Woohoo! So another $1.11 for continuous compounding versus monthly. So that was worth 4 points for B6. So on to number 7. I'm coming to the front board. Number 7 says graph this function. F of x equals the log base 3 of x. So again, our brains don't really think very well in logarithms, so we're going to rewrite this as an exponential function. So we're going to take 3 to the y equals x. So that's really what we want to graph as our basic function. And since it's written this way, we're actually going to pick for y instead now to get x. So again, in a logarithmic function, the range is all real numbers. So we should definitely pick negatives, positives, and 0. Okay, so picking for y, -2, -1, 0, 1, 2, positives and negatives. So 3 to the -2, we're going to square it and invert it. That's going to give you 1/9. 3 to the -1, you're going to invert it. That's 1/3. 3 to the 0 is 1. 3 to the first 3, and 3 squared is 9. So taking those points, we're going to graph on the plane, and this was worth 3 points, by the way. Counting by ones here. Okay, so graphing in blue, we have these points, 1/9, -2. So write 1/9 down 2. 1/3, -1. Write 1/3 down 1. 1, 0. 3, 1. Write 3 up 1. And 9, 2. Write 9 up 2. So here's f of x. A logarithmic function is an exponential function, is a one-to-one function. Its domain is 0 to infinity. Its range is all real numbers. It has an x-intercept at 1, 0. And a logarithmic function. Those are the basic properties. So now we're going to go to question number 8. So question number 8 says, use the function in number 7 to complete the following questions. So 8a, which is worth 3 points, says graph g of x equals -2 times log base 3 of x. So as we did before, we're going to use our same points that we had for f of x to do our translation or transformation function g of x. I'll be sharp. So probably somebody took a picture of the ones I just erased. All right, so I'll go in green here. So we have nothing in parentheses with x, nothing affects x. So we're going to take our same x points, and I'm just going to repeat them just for color here. So nothing, we had no horizontal shift. So x is still 1/9, 1/3, 1/3, and 9. But for y, we have this -2 out front, which is both a stretch by a factor of 2 and a reflection across the x-axis. So that affects y. So we're going to go to our original y points, and we're going to multiply by -2 times y from the original y's. And again, you could also just pick values and do it this way, but it's easier to use the original basic points and do it this way, as we said here. So -2 times -2, 4, -1 times -2, 2, 0 times -2, 0, -2 times 1, -2, 2 times -2, -4. So this is going to take this same function and stretch it and reflect it across the x-axis for the negative. So graphing the green points, write 1/9 up 4, right 1/3 up 2, 1, 0, 3, -2, right 3 down 2, and 9, -4, right 9 down 4. On the same plane, so we can see what's happening here. That a little better. There we go. So as we see, we've taken the original blue function, y equals log base 3 of x, and we've stretched it by a factor of 2 and reflected across the x-axis. So then we can use that to answer our questions for 8D, which says identify any asymptotes with 2 points. So normally we have a vertical asymptote of x equals 0. We didn't do a horizontal shift, so we're still going to have the same vertical asymptote. Of x equals 0. By the way, when you write asymptotes, remember you have to write the equation. You don't just say 0, you say x equals 0. In C, is this function increasing or decreasing? The green function, increasing or decreasing? Decreasing from left to right. Normally when you have a base, as we did 3 here, it would be increasing, but the reflection made it a decreasing function, only because of the reflection. In D, domain and range of the green function, this is worth 4 points. So the domain is normally 0 to infinity on a logarithmic function. We did not have a horizontal shift, so that remains the same. 0 to infinity, not including 0. Notice it gets closer and closer to 0, but not quite there. The range is all real numbers. Stretching it and reflecting it is not going to affect all real numbers. So the range is negative infinity to positive infinity. So on to number 9. So on to the equations. So number 9 says find the exact solution to each of the following equations. So 9a, we're at 3 points. We have log base 2 of x minus 1 equals 4. All right, so we want to solve this logarithmic equation. So again, our